this last section is all about metallic bonds, and we have to make sure we have a couple of things straight. So these are going to be pure metals that we're talking about. So it would be like just talking about zinc or copper or sodium even. They're not, and this is a big not, they are not ions. They are regular atoms. And remember, plain atoms have an equal number of protons as electrons. And so these pure metals, they're crystalline solids. And every point in the crystal lattice is occupied by an identical atom. So again, not ions like we've been talking about for most of this chapter. So again, we're dealing with crystalline solids. Every point on the crystal structure is occupied by that identical atom. And the valence electrons are mobile, meaning they can move. And they do move. They drift from one metal atom to another, kind of like they're free-range electrons. And they're also referred to as delocalized because they no longer have a specific location. So here we would have the nucleus of an atom, and then these electrons, they have the ability to just float around those nuclei. And so the metallic bond is created by the attraction of the stationary metal cations. So these are the cations because they're the nucleus. They're positively charged. And the surrounding mobile electrons. So there's no anions in this. It's just the positive nuclei surrounded by free-floating electrons. So properties of metals is because they have those free-flowing electrons, they can conduct electricity and heat. And they do that very well. They have something that we call luster, and this is the ability to reflect light. So like gold and silver and all those metals we use for jewelry, they get used for jewelry because they're shiny. They reflect that light. And this is because they have electrons that get excited. And they move to a higher energy level. And immediately fall back to a lower level. And as they fall back, they emit light. Metals are malleable and ductile. Malleable means able to be hammered into sheets. So that would be like making like aluminum foil. or pounding aluminum into a thin enough sheet to be molded into like a pop can. They're ductile, which is the ability to stretch into a wire. And so these properties of metals are possible because those free-flowing electrons fill the spaces between the cations or the nuclei when a force is applied to the metal. So it prevents that shattering effect that we see with the ionic bonds. Those electrons move to keep the positives away from the positives, and so they no longer have the ability to shatter. So metals have what we call closet packing, and this is the most efficient way to pack spherical objects. And so there are 3 types of closet packing. They can be cubic body centered, cubic face centered, or hexagonal. And the elements listed below each of these are the elements that exhibit each of these closet packing. So iron exhibits cubic body centered, aluminum and nickel and silver and gold have cubic face centered, and hexagonal would be like zinc and magnesium. So with cubic body centered, there's 8 corners. So 1, 2, 3, 4, 5, 6, 7, and 8 is back there. And there's 1 atom in the center. So right there. The coordination numbers, I'm going to just call them CNs, of each atom is going to equal 8, because there will be 8 of the opposite charges around that. Cubic face centered, again, has 8 corners, and there's 1 center atom on each face. So that would be like right here is that 1 centered on this front face here. Here is this center atom on this face up there, and that's where we get that face centered. Whereas this center atom is literally in the middle of the cube. Here our coordination number for each atom is going to be 12. The hexagonal, you can see that there's a hexagon on the top and the bottom, and there's an atom on the face of that hexagon. Your coordination number for this is also 12. So we can create alloys out of metals, and this is a mixture composed of 2 or more elements, and at least one of which has to be a metal. And you're actually familiar with some alloys like brass, bronze, and steel. And so brass is a combination of copper and zinc. Bronze is a combination of copper and tin. And there are different types of steels. The main metal here would be iron, and it could mix with any one of these or any combination of those to make different types of steels. Substitutional alloy atoms will replace each other in the crystal lattice. And interstitial alloys are smaller atoms that can fit in between the larger atoms. So like the carbon, if carbon were to be in the steel, would fit in between. So here would be our carbon atom, the like iron atoms. So that's just a quick little look at some metals. And the biggest thing to remember is here we're dealing with atoms and not ions.